Hi everyone, welcome to Bayes' theorem once again. Remember, in the last video I left you with this question and almost half the solution. Yes, today we are going to take this question further and many more questions on Bayes' theorem. As the video suggests, this is application of Bayes' theorem. Well, needless to say, if you don't know what is the need for this theorem or how is it derived, please do check out the previous part. And for now, let's dive straight into the topic. So, let's read the question one more time. It says an insurance company insured 3,000 scooters, 4,000 cars and 5,000 trucks. Now, probability of accident due to a scooter is this car and truck. So, this is the data given to us. One of the insured vehicles meets with an accident. Find the probability that it was a car. So that means the event that has already occurred is that the accident has happened. You have to find the probability of the cause that it occurred because of a car. So if you have a look at it, we define E1 as event of driving a scooter, likewise E2 as a car and E3 as a truck. A let us call as event of occurrence of an accident. What we have to find is when accident has already occurred, what is the probability it happened due to the car? Now, moving to the hypothesis or what we require to apply Bayes' theorem is existence of a partition. Well, check out the previous part for details. So, we will say each of them EI intersection EJ is going to be phi for all I not equal to j and ij varying from 1 to 3. This means they are mutually exclusive. E1 intersection E2 is phi. Of course, if a person is driving a scooter, he cannot be driving the car at the same time and so on and so forth. So all such combinations will give you a null set. If I take union for all of them, they create the entire sample space as per the question. And finally, the probability, if I check, probability of driving a scooter would be 3,000 out of 12,000. So, it is 3,000 out of the total 12,000, which is 1 by 4, which is certainly well within the range 0 and 1. So on, probability of E2 would be 4 by 12, so 1 by 3. And likewise, probability of E3 will be 5 by 12. Probability of E2 by A, as per the Bayes' theorem, we flip this, that is A upon E2, into probability of E2. And the denominator is going to be the total possibilities. So, A upon E1 into probability of E1. Now for the second one, I repeat the numerator, A upon E2 into probability of E2 and A upon E3 into probability of E3. Now once we've written all of this, all you need to do is put the valued value and you'll be done. So what do we understand by probability of A upon E2? That means probability of an accident when person is driving a car. Once again, probability of an accident when person is given to be driving a car, which is this, because it says probability of accident due to a car is 0.03. So I put 3 by 100 here into probability of E2 we already know is 1 by 3. Likewise, now we will substitute for the denominator. So, probability of an accident when person is driving a scooter is 0.02. So, 2 by 100 into probability of E1 from here is 1 upon 4. We repeat the numerator here. And probability of an accident due to a truck is 4 by 100 into probability of E3, which is 5 upon 12. On simplifying everything, you get a very simple answer, which is 6 by 19. Please try this out and look at the entire question once again. Okay, again a very interesting question. It says given three identical boxes labeled 1, 2, 3, okay, each containing two coins. In box 1, both coins are gold. In box 2, both are silver. And in box 3, there is one gold and one silver, right? A person chooses a random box or chooses a box at random and draws out a gold coin. What is the probability that the other coin in the box is also gold? Now, you might feel, how do I get to know? They're not asking me from which box. However, if you read it carefully, they're saying, what is the probability that the other coin in the box is also gold? So they are hinting towards what is the probability of the box being the first box, because box 1 is the one where both coins are gold. So I have this format laid out. Let E1 be event of choosing box 1, E2 choosing box 2, and similarly E3 choosing box 3. A we usually take as event which has already occurred. So we take it to be event of getting a gold coin. Now we have to find what is the probability when the gold coin is out that the other one was also gold, which is E1. So this is what we have to find. Very quickly, once again, your EIs will have nothing in common. By this I mean, if somebody is choosing a coin from box 1, he cannot be choosing the coin from box 2 simultaneously or from box 3 simultaneously. So there's nothing common. Next, E1 union E2 union E3 exhausts the entire sample space as per the question. Finally, probability of E1, that means choosing box 1, choosing box 2 or choosing box 3, they're all equally likely to happen. I mean, a person can choose any box at random. So it's all 1 by 3. So this happens to be 1 by 3 for each of them. That's it. Now, all you need to do is put the formula. Once again, flip this into probability of E1. And now, write the numerator for all possible events. Please note in your papers, usually the question doesn't go beyond 4 events. So it could be 2, 3 or 4. So putting this time the numerator is the same as the first term here. This is our denominator. Now let's start filling up the values here. This one tells probability of getting a gold coin from box 1. So probability of getting a gold coin from box 1 is of course 1 because both the coins are gold only. So the probability is 100%, which is 1. Probability of E1 is just 1 by 3. Now probability of getting a gold coin from box 2. Since box 2 has both silver, so of course the probability of getting a gold coin has to be 0. And lastly, probability of getting a gold coin from box 3, where they have equal coins, so it is half. On simplifying all this, you will end up getting the final probability as 2 by 3. That means probability of getting your box 1 when the gold coin is already out is 2 by 3. Look at the third question. It says bag 1 contains 3 red and 4 black balls and bag 2 contains 4 red and 5 black balls. One ball is transferred from bag 1 to bag 2 and then a ball is drawn from bag 2. The ball so drawn is found to be red in color. Find the probability that the transferred ball is black. Let's try to pictorially represent this situation. So I have bag 1 whose composition is 3 red and 4 black balls, and I have another bag 2 with 4 red and 5 black balls. So one ball has been transferred. I don't know which one. It could be red, it could be black. And then from here one ball is drawn which turns out to be a red one. You have to find the probability that the transferred ball is black. So here writing the events might be slightly tricky. So this time we have these two events, event that the transferred ball is red or the event that the transferred ball is black. And the event that has already occurred is that we have drawn a red ball from bag 2. So AB, event of drawing a red ball. We have to find the probability that it is the transferred ball is black, so E2 by A. Of course, once again we say E1 intersection E2 is phi. Also their union exhausts our sample space in the question. Probability of transferred ball being red depends on the first bag. So what is the probability of actually picking the red ball and transferring it is 3 by 7. And similarly, P of E2, which is probability of transferring a black ball, would depend on how I pick the black ball from here, which is 4 by 7. So both of them are lying between 0 and 1. Let's apply the conclusion of Bayes. So this is how we write the formula, and now let's start applying the values. So probability of drawing a red ball when a black ball was transferred. So suppose a black ball was transferred here, so that increases the black balls by 1. Now what is the probability of getting a red ball? It will be 4 upon 10. Probability of E2 is 4 by 7 as it is. Look at this now, probability of drawing a red ball when the transferred ball was also red. So this time that means my red ball increases and I have to draw the red ball, so it becomes 5 by 10. Probability of E1 is 3 by 7. And here we just repeat the numerator. The answer is 16 by 31. Isn't that simple? Please go through the question as well as its solution once more. I simply love this question. Just read it out once. It says a letter is known to have come from either Tatanagar or Calcutta. On the envelope, just 2 consecutive letters are visible, which are TA. What is the probability that the letter has come from Tatanagar? So how do we go further with the question? First of all, this point is very important that the letters are consecutive. So it's not any random letters being picked up. They have to be consecutive the way it is seen. Now here, if I define my events, so we can say let E1 be the event of getting a letter from Tatanagar and E2 be Calcutta. And A is the event that TA is visible. So event of getting a TA. Right? We have to find if this TA is visible, what is the probability that it has come from Tatanagar? You can jolly well get the hypothesis in place. You know E1 intersection E2 is phi. We know E1 union E2 exhausts the sample space in the given system. Probability of getting a letter from Tatanagar or Calcutta, since there is no preference mentioned in the question, so it's an equally likely event, and we get this to be half. Now, applying the formula, I'm sure by this time you know this formula at the back of your hand. So now proceeding, all this has been quite simple. The only challenging part is how to get this or this. So let's see. Now this means probability of getting a TA when the letter is from Tatanagar. And for this, just try and see. It says the letters are consecutive. So getting a TA. Now, first of all, how can you see anything? I can either see only TA on my pack or I can see AT. Next, I see TA. Next, we can see the combination AN, or we can have NA, or we can have AG, or we can have GA, or we can have AR. These are the possible 2 consecutive letters that you can get. Your Tata Nagar. So from here, how many times do you see TA? I see TA twice out of the 8 possible outcomes. So here I get 2 by 8. Probability of E1 is anyway half, and the same term could be written over here. Next challenge is probability of seeing TA when the letter is from Calcutta. So let's analyze your word Calcutta again. So if the letter is from Calcutta, I get either CA, or I can see AL, or I can see LC, or CU, or UT, next TT, and next TA. This time we have 7 combinations, out of which TA is occurring only once. So here I get 1 by 7 into half. Now the answer on solving would be 7 by 11. I hope you had a fun time solving these questions. Now go through your books, start solving many more. Please do write in the comment section if you want me to take up more questions on the topic. And you know the drill. Like, share and subscribe. I would see you with the next video. Until then, bye-bye.